Hey everybody, it's Bruce and the dog on the floor, and today we're here to talk about building a hardware circuit that we're going to control through the Nerves Circuits library. It's going to be a fun episode with a little bit of a twist. We're going to be working with hardware, so we'll talk about our shopping list next. Okay, so let's talk a little bit about what our shopping list is going to look like. First, we're going to build the project on breadboard, and you can see that I already have established a breadboard project for connecting to an LED. And so I have two male to female jumper cables, and we'll be able to reuse one for the entire project. And then we'll also need 3 resistors, and anything from 100 ohms to 500 ohms will work. And then you can see that this is a yellow LED, but we'll also use a blue and a red one. They don't have to be different colors, but it's kind of nice to be able to see, to tie the GPIO pins that we'll be using and see how that works. So the rest of the equipment is the same thing that you needed for the first set of videos, which is a Raspberry Pi, some type of a connection cable. I use a MacBook Pro, so that's what we're using. Here, so we have MacBook Pro, Lightning style connector to micro USB that we're looking for on the Pi, and then the micro SD card. And so if we're using a Raspberry Pi Zero, but you can use a variety of targets. I recommend this one for kind of the smaller hardware projects because they're really cheap. With the onboard Wi-Fi and the header pins, anywhere between 10 or 15 bucks, and that's a great price for starting out with hardware. Let's talk about what this circuit does and what we're going to do with it next. Okay, so this is the circuit that we're going to build, and you can see that we're using an electric schematic, and there are components that are in black, and there are gray lines, and the grays will either be with jumper wires, or we'll take advantage of the breadboard that we're going to plug this into. Now you may not see it, but some of the holes on the breadboard are connected, and we'll talk about that in a second. What's happening is that we have this GPIO pin, which stands for General Purpose I/O, and we could actually choose to use that for input or for output. We're going to use it for output, and that means that we can write either a high voltage, which is going to be 3.3 volts, or we can write a low voltage. So we can change that GPIO pin to either output power or not based on our requirements. So that's pretty cool. And then, so that's going to flow into our resistor, and that's going to flow into the positive end of our LED, and it's going to flow out of the negative end of the LED. And that might be surprising to you if you're used to building circuits and light bulbs will flow in either directions, but LEDs are unidirectional. This is what our circuit looks like, and we're going to wire this up to our GPIO through resistor, through the LED, and then out to the ground. And you might say, well, there's a lot of pins. How can we tell which pin to wire things to? We're going to do that next. So here's how this is going to work. Raspberry Pis have different pins. Those are the little pins that point up, that was in the top of our little video. And each of those pins has a purpose. So how do you find the purpose? So there's a site called pinout.xyz, and this talks about the various different kinds of pins. So there's a couple that we'll look at, like these 2 pins, 4 and 2, provide power, so they have red circles, and then the pin 6 is a ground. And so if I wanted to build a circuit that always had power, 5 volts of power, I could access that through the Raspberry Pi, right? So I could connect something through this 5 volt power, and then run through my circuit and then come back into the ground. Well, we don't need those. We need GPIO pins, which are also called General Purpose I/O pins. 26 is one of the GPIO pins, and one of these is the ground, which is great. So we could take the 2 in the corner. So after we orient ourselves, and in the Raspberry Pi that I have, these are on the opposite end. These large pins, the big numbers, are on the opposite end of the card reader. So that's how I kind of know where they are. And so I can take these pins and I can grab the two in the corner. So these would be the ones pointing to the main side of the board and away from the outside edge of the board, and the ones the farthest away from the card reader. And I also need to remember the name of the pin. These are called Broadcom numbers. So this is 26. So I could also grab a couple of the pins further up. So maybe we'll use this pin 37 and then 33 and then 29 and then the ground on the bottom. So our plan is to use the ground for all of these. So what we'll do is wire the ground into our breadboard in a row that's specifically built to kind of connect several things to the ground. So we'll tie this to power, and then we'll tie each of our pins, each of our LEDs to one of these GPIO pins. We'll use 26, 13, and 5 and tie those to various LEDs. So we'll have 3 circuits that look like the circuit that we want to build. So remember, each one of our LEDs is going to need its own circuit. So we'll connect all the grounds on the far right to the same ground pin. That's pin 39. And then we'll use those 3 Broadcom pins, GPIO pins. So the left-hand side is going to be tied to either that 26 or the 13 or the 5 based on that pin out diagram. And when we're done, we'll have 3 LEDs kind of side by side with only enough breadboard to between them to kind of give us room to wire the circuits. So we'll have a pretty cool effect that way with being able to control red, yellow, and blue LEDs. That's going to be pretty cool. And then we'll control that through the Raspberry Pi by just using the circuits library. So let's go ahead and wire up our circuits. Okay, so here's how the breadboard is going to work. It turns out that if you look at these pieces of breadboard, that these 2 long rows are connected underneath. So the 2 columns on the left-hand side represent power and ground. And so these are all connected in a row from the top to the bottom. And it turns out that each row horizontally is also connected. So often what you'll do is take advantage of the wiring between each row to connect things that might be connected with circuit boards or wires instead. And so what we're going to do is wire up a connection that looks like this. So this is how the circuit that we built for the Groxio book looks right now. So we start with the Raspberry Pi GPIO. We flow that through a resistor. And you can see how we're using the breadboard, the horizontal rows on the breadboard. And in blue, those connections represent the wires underneath. So I plug in the GPIO to pin, which is the second pin from the far end, and I connect that to a resistor, connect the resistor. The resistor is plugged in the same row as the GPIO, and the other row of the resistor is pointed into the long leg of the LED. And then the other leg of the LED is plugged in to the ground. And so what we're going to do is move that wire from the GPIO ground to the rail that represents the whole ground wire. And since those are all connected together, I can put another wire from the Raspberry Pi ground to that rail. So now all of our circuits are going to be able to share the same ground. And so this is going to make it a little bit easier to work with the pins on our Raspberry Pi. And we'll do that next. All right, so the first thing that we're going to do is you can see that we have this black wire. This LED circuit is using the black jumper right here as a ground. And what we're going to do is plug this into this long row that's next to the blue line. All of these are connected, so we can use these as the ground for the whole circuit. So maybe we'll take this over to this end like this. And then we'll take one of these short cables like this, and we'll pick up the end of that LED and plug that back into the ground. So you can see that what we're doing here is that we're actually going to use the same ground. So this whole length is connected on the breadboard. So we'll use this whole ground wire to wire all of our circuits together, and that's going to make it a little bit easier. Then we won't have to worry about finding 3 different grounds, and that'll make the wiring to our individual pins a little bit better. So next we're going to walk through the circuit that we've built so far, and we're going to test it by connecting our Raspberry Pi to the computer and actually opening the pin and using it. So what we're going to do is plug in the Raspberry Pi, and I'm plugging it in right now. It's easy for you to say. Okay, so that's plugging in. You can't see it, but I'm seeing the indicator LED on the Raspberry Pi that's flashing. So I'm going to let this finish doing its work, and then I'm going to shell into it. And the way I'm going to do that is with SSH, and I'm going to type circuits@nerves.local. We're using the Circuits Quick Start firmware that we've already burned, and you can check out the first 2 Groxio video on what that looks like. So I'm going to let that fly, and it looks like we're getting a connection. I'm typing circuits, and we're on, and I'm going to alias Circuits.GPIO. That's perfect, and I could say GPIO .open. And remember, the pin number that we were using is different from that Broadcom in pin out. So if I look at the pin out, we're looking at this pin that's right down here near the bottom, and that's pin 26. So I'm going to open that pin 26. Oh, and it's going to ask me to open that for output or input. I want to open it for output. Okay, so I got a successful result, and we can grab that. We can go back in IEX history and say, okay, in my LED, which is represented by that GPIO pin because it has a circuit on it, and I'm going to say line V2, which is that line right here. So this is just calling the function V for the history, line 2 of the history, which is going to give me this result. And so now I have access to an LED, and this is an Elixir reference, and that reference is just a unique identifier that's unique worldwide. So these will not be repeated, and ours is going to allow us to reference that LED. So I can write to it. I could say GPIO.write, and then the pin, or that GPIO pin, which is marked by that reference, and then the value we want to write, which is 1. Okay, and so that came on. You can't see it, but I'll show you in a second. Now I'm going to write a 0, and that went off. So I'm going to switch over to the camera view so you can see what I'm seeing. Okay, so now you can see the project. We have remember the ground pin is connected to the rail here, and then we jump over to my circuit, and that circuit is on the same side as the short leg of my LED, and then the long leg of my LED is on the same row as the resistor, and the resistor connects to the GPIO pin that is on the same row as the GPIO pin. And we're going to replicate this circuit a number of times, but first we want to try out and make sure it's working. So I'm going to do a GPIO write of 1, and it's on, and then I'll do a write of 0 to the pin 26, and that's off. So that's great. This is doing what we want it to. So now I'm going to unplug my circuit because I don't want to mess with the Raspberry Pi. as we're working. So I'm going to take this and I'm going to unplug. And so we are set, and now we're ready to work on the circuit some more. So let's go ahead and set up a second one. So I'm going to take this short jumper and I'm going to wire that to ground. And then I'm going to take the short leg of my resistor. So these have long legs and short legs. So that short leg I'm going to put next to that jumper wire. And the long leg I'm going to put in the other hole. These old eyes sometimes have trouble with these, but I think I did that all right. Okay, and now I'm going to pick out another resistor, and they come straight, right? But I need to bend the legs down like that. There's one leg, there's another leg, and so that's good enough. So I'm plugging this in. So this resistor, you can't tell, but it's on the same row. See if I can give you a little angle. See, that's on the same row as the long leg of the LED. And so now I'm ready to take another jumper cable, and this is a male-female one, and we want to wire this to the GPIO. So we're basically going to skip one and pick up the next one. And I think that is pin 13. I recognize this. I wanted to pick out this pattern. And that looks right to me. So I took it off to double check, and I can't get it back on there. All right. These old eyes don't see those pins so well anymore. All right. And I'm going to pick up the other end of this jumper, and I'm going to put it in the same row as this, as the resistor, which is connected to the long leg of this cable. So now I have a second pin, and so we could play the same game that we did before. So I'm going to plug this in, and I'm going to let you view this camera while I work on this. And so you can see that the LED is flashing as I boot up. And I'm going to open, I'm going to SSH out, I'm going to let that finish booting up, because I can't talk to it yet because it doesn't have the, okay, now it looks like it's ready. So I'm going to connect to, and there's local, and that's circuits. Yeah, I think I'm going to change all my passwords to circuits. Okay, so this is, I need to open the pin, but this time I need to take a peek at pin out. And so pin out is telling me that we skipped one, that's 35, and then we pick this up. So we're looking at 13, and then we're going to skip one and pick up 5. So let's see if 13 will let us turn that circuit on. So I'm going to do the alias, Circuits.GPIO, and then I'm going to say OK. And then I'm going to call this one red, because it's my red LED, and I'm going to do a GPIO.open, and I'm going to open 13 for output. And that looks happy. So I'm going to say now, I'm going to say GPIO.write. I'm going to say red. I'm going to give that a 1. Let's see what kind of results that I get from that. Yep, and you can see that my red LED is on. So now I should probably say yellow is equal to LED. And now, so I'm saying yellow is equal, oh, I'd never opened, so I'm going to open yellow. So I'm going to open, well, we'll do this a little bit later. So right now I just want to verify that these can work. And now I'm going to unhook the computer, and I'm going to say exit. Well, I should have done that in a different order. So, so I'm going to close my IX terminal, and we're going to hook up the last one. I'm not going to show you wiring up the last one because it looks identical to the other ones. So I'll go ahead and do that one. Then I'll be back to do our last little demo. And then we're done. Okay, so you can see I've wired at the middle one where I have GPIO 5, which is also the 5th pin from the inside bottom right, where the orientation is with the card reader on the far side. So actually it's it's the 6th pin. So really I have GPIO, I have the ground representing the one in the corner. I have the GPIO 26, I think, that's sitting in that's sitting right next to it. And I skip one and I pick up GPIO 13 or Broadcom pin 13. I skip one and I pick up pin 5. And so pin 5 is tied to the blue LED. So this wire is connected to the resistor, and the resistor is connected to the short leg of the blue LED, and then that's connected. The long leg of the it's connected to the long leg of the LED, and the short leg of the LED is connected to the ground, which I pick up by wiring to the ground rail. So we're off to the races from that perspective. I'm going to go ahead and shell in. I'm going to leave this connected just so you can see them blink. So I'm shelling in. I'm going to plug things in. Look at that. This LED came on. Let's see if we're wired up incorrectly or if it's just left on as just kind of an icon of the hardware. So we might have to initialize this when everything comes fully up. But that's okay. That's part of dealing with hardware. These pins are used for different things, different purposes during boot up as different hardware is connected. So it's asking me to log for password. I'm going to type circuits. And so I'm going to do what we did before. I'm going to, you can't see it, but I'm going to alias Circuits.GPIO. And I'm going to say the OK, and the blue tuple is equal to GPIO.open, pin 5 for output. Okay, that worked okay. And now the moment of truth. Looks like it turned off when I opened it. So can we write to it? So I'm going to say GPIO.write. And I'm going to write blue 1. Okay, and that turns on. And if I write blue 0, that turns off, which is perfect. So I think that we're going to do some console programming next, and then before I run these programs, I'm going to bring you back over here. So I think that we're going to do a little bit of Elixir wizardry with streams to kind of repeat a function. You stream and repeat of a function to blink all of these in succession. We're going to do that all from the console, kind of as our big demo to finish. So let me switch you over to the console side, and we'll do that next. Okay, so you can see what we've done here. We just shelled in with SSH, and then we entered the password, which was circuits. We aliased this one. We opened up blue. We wrote twice to it. Let's do the same pattern. Let's open up the yellow. The yellow is on what, 26? And then we'll write yellow 1 and write yellow 0. That works, so that's correct. And then let's open up the red. And the red is on 13. It's easy to remember. It's half of 26. That's great. Red 1, write red 0, and that's working correctly. Okay, so now we're going to write a couple of console functions. I'm going to say blink is equal to, let's say, it's a function that takes an LED, and then I'm going to GPIO dot write LED LED1, and then I'm going to do GP dot write, or I'm going to do a sleep, or process dot sleep. Let's sleep for a quarter second, or how about 100 milliseconds, a tenth of a second? That's probably too fast. How about 150, 200? So let's sleep for that long, and then let's do a write of LED to 0, and then let's sleep again. How does that look? This needs to be a semicolon. Is that correct? Let's see. I think that's correct. Yeah. Okay, so if I say blink red. Okay, so I got a blank there. So what we're going to do is string dot repeatedly, and we need a function. And I'm going to say blink dot red, blink dot yellow, or how about blue, and then blink dot yellow, right? And so I'm going to let this fly, but I think I'm going to cut over to the camera view before I do that. Well, let's make sure it works. Okay, and so now I'm going to let that fly. Oh no, this is a stream. So enum.take 3, right? So I'll be able to blink 3 lights. And there we go. Okay, so what I did, so this is going to return essentially a function that will do this over and over, and then I told Elixir how many times to go through this cycle. And so let me show you what that looks like from the camera view. So we'll do that next. Okay, so this is my project, and I'm going to take this, I'm going to go back to my console, and I'm going to do that stream repeatedly, and I'm going to take, I don't know, 20 or so. Yeah, and so this is going to cycle through 20 times. That's 4, 5, and go on and on and on. So what we've done is we've essentially raised the abstraction for dealing with hardware, and we can build our software in layers using these very same techniques. So we're going to use the same techniques that you saw in my book called Designing Elixir Systems with OTP. And we're going to use those techniques to build software where we can essentially layer on one piece after another after another. And we're going to be able to use complex Elixir features like streams and like OTP to be able to give us more productivity, more reliability, more concurrency, and any more as you're building software for embedded systems. That's becoming more and more of the game, and that's an excellent thing. For Bruce and the dog on the floor, this is Groxio Learning.